In number 4, the equation that we're given is not a linear equation. Now it's a quadratic equation because the highest power of t is 2. We got a negative 16t squared term. So I know the graph of this is going to be a parabola. The first question we're asked is how long will the ball be in the air before it falls back to the ground? And s represents height, so I'll just set that equal to 0 and start solving. And the easiest way to solve this is to factor out the common terms on the right hand side. See, I can factor out a t and a 16. And I'll go ahead and factor out the negative as well. After you factor that out, then you're going to use the fact that if you have 0 equals one number times another number, then one of those two numbers has to be 0. So you just set negative 16t equal to 0, and you set the t minus 4 equal to 0. Solve both of them. The t equals 0 answer is telling us that at the very beginning, the height is 0. But what we're looking for is how long does it take to fall back down to the ground, so that's the t equals 4. Second, we're asked to find what's the maximum height reached by the ball. And to find that, we're just going to need to look at the vertex of the parabola. If we graph it, we know it's going to start low, go high, and come back down. So I want to find that high point. We've talked about before that you can find the vertex by doing negative b over 2a. So if you plug those numbers in and reduce, you get t equals 2 seconds. And that makes sense. It's halfway in between t equals 0 and t equals 4. The parabola is symmetric, so when it starts at the bottom and goes up and then comes back down, between 0 and 4, halfway in between, is where the maximum would happen. And then to find the actual height, you just go back and plug that 2 into the height equation, and you get 64 feet for the max height. And then the third thing that we're asked to do is graph the equation with a vertical s-axis, so the height is going to be vertical, and then a horizontal t-axis. So we'll let the t be what we usually call the x-axis. And then when we're scaling this, we know we want the height to go up to 64, and we want the time to go out to 4. We know exactly where the vertex is. We know where the two t-intercepts are, what we usually call x-intercepts. So we'll plot those points, connect them with a parabola, a smooth line, and that's the graph. This is called a quadratic model because the graph is a parabola instead of a straight line or something else. And if you look at the equation again for height, the highest power of t is 2. It's a polynomial with degree 2, so that means it's going to be quadratic. We don't need the part that's down below the t-axis.